I'm going to talk to you today about facility programming from the Vacaville site and how that's related to see and solve the right problem. The business case that we started with at the site was this idea that we had evolving demands and that we needed more product faster. We needed to build capacity to deliver those products, and as a site, we were already quite maxed out. We are sole sourced producer for Perjeta, as well as Ocrevus, and the Actemra version that was being used by COVID-19 patients. Since then, we've also added in there Nabucco from Regeneron, and essentially the business case speaks to the fact that we need to be able to produce these life-saving medicines faster, more efficiently, with less defects, but at the same time being able to do this without sacrificing safety or quality or burning our people out. And so what we drove to do was to build a system essentially to try and drive these capacity improvements. And we call that facility program. And the goal of the facility program is to ensure that work proceeds at an even and efficient pace throughout the plant, but maximizes production output and eliminates bottlenecks in real time as we go, all without overburdening our people. The way we started that is we did do a value stream map for both Perjeta and Actemra in the two plants, CCP1 and CCP2. And from that diagnosis of using that mapping activity, we started designing standard work or standard level loaded schedules for our operations. And the team drove to do active capture of all of the different processes within manufacturing. We also had a team that went after specific bottlenecks within our production site that we called the capacity levers team. And really those led to projects, and those would be physical type capacity improvements that you normally would go after. But facility programming was more about trying to program the facility and drive the efficiencies and remove some of the hidden factory wastes that are within the site. So to do that, we started looking at finite scheduling and the way that we scheduled operations, but also maintenance activities, validation activities, automation activities, and so forth. And essentially, we want to set up a whole facility program. One of the things we observed was that a lot of our operations, whether they be maintenance operations or manufacturing operations, were not starting on time. We had float within our schedule, the way that we planned our schedule. We had a plus or minus 4 hours of schedule variability. But then even within that, that's sort of the start time, could start as much as 4 hours delayed. Operations are not starting within that window already. They could be even further delayed. So all of the detailed planning and scheduling that the scheduling team might do essentially was not being leveraged. And then that's also a certain amount of capacity is in that hidden factory. So we did set up a measurement system and set up a new KPI for us that we stole from SASTRiP production, but this idea of on-time starts. Is the operation starting on time? And if not, why? And why not? And just trying to capture that data. We put in a shift tool, a shift change tool that helps us to capture this on-time starts data and is directly connected into the standard level loaded line manning worksheets that the team developed for manufacturing. You'll see that in another video. And the output of all that is ultimately we want to be able to then make adjustments to the facility plan, the operational program, through data analysis. So the seeing and solving the right problem, it helps us to see what are the things getting in our way, but then we can also feed that back into our master data, making sure that our SAP master data is set up to our current capabilities. So when we make improvements to, say, an operational step, that gets reflected in SAP, and therefore the planning and scheduling is appropriate to that. Another component of that is the workforce models and how we've set that up. Because we've set up a system now that essentially is driven all the way down to the individual operator, the line manning, we need to be able to update how we plan strategically for the workforce that is supporting that standardized plan. And so this sets up a system essentially following the see and solve the right problem, but at an enterprise level, not an individual group level, but really trying to think about what is that the business needs. And then ultimately, before the pandemic, we had started putting this into an operational OBEA so that all of the organization could see together and act together on the same data. We've put that a little bit on pause because of the pandemic, but that's still part of the long-term plan of facility programming, is having this central nerve center, if you will, that helps to connect the suppliers and customers together and really optimize our processes as a facility. The next steps are really to start developing the standardized work for the individual tasks. Right now we have a line manned by individual tasks, but those tasks themselves may not have standard work today. So developing that and then using that value stream map to go after improvement opportunities that really help us drive that end-to-end thinking for the site. So as a site, some of the things we did do is we worked on the daily rhythm and schedule, trying to reduce the time from initial operational meetings all the way to escalation throughout all the levels of leadership. And that was part of operation, or sort of optimizing the operational huddles. Like I talked a lot about, we worked on line manning and beginning to do standardized work. So we have standard work combination sheets for all the processes. We now need to create that into standard work. We also have a big focus on the equipment availability side of things. So through the measuring of on-time starts for maintenance as well, and working on reducing maintenance changeovers and going after what are the top bad actors within the maintenance activity. That's essentially oftentimes the top Pareto of why something might not start on time. All of this is also focused on level flow. So thinking about how we improve the material and information flow through the entire facility. The results to date for doing this work has been an increase in number of days in plant at about 29 days. The reason for the variability there is that we are able to reduce product changeovers down to 1 day, except that we're putting a lot of maintenance activities into that window. So the reality is it's closer to about 4 days product to product changeover within CCP1. And then we'll start looking at CCP2, which has a much longer product changeover. What that's resulted for in 2020 has been an increase in about 19 runs at a 4.7 run rate. And because that's the primary driver for our sole source products like Perjeta, that's actual products that can go to patients. And we've done quite a few individual improvements that are listed there. So ultimately, facility programming is trying to see and solve the right problem into that daily operational view, not as something extra that we're doing, but is the work that we do every day. And we're trying to balance the idea of perfect quality, on-time delivery, and the right speed, but balance the workload to produce the maximum output that we can, or the capacity for the site. So thank you.